Okay, so for today, I will continue with the equilibrium discussion on the equilibrium. Okay, so any of you here knows what is equilibrium condition? Anyone? If there is no
Maybe
one,
it's where anything is stay. I mean, didn't move at all.
didn't move at all.
Uh,
Not necessarily didn't move at all.
When the total forces and the moment acting upon a body is zero.
Yeah, correct. When the total forces and the total moment, the total force and the total moment acting at a body is equal to zero. Equal to zero. That's equilibrium condition. Actually, yeah. Uh, Seems like Azar is quite good in reading this Azar. Correct, right?
Uh,
These are
a bit of
everything.
that and a bit of my memory.
Okay, because everything is there. Okay,
Yeah.
that's equilibrium condition. So the total forces and the total moment acting at a body is equal to zero. What's the effect on that? What's the effect which will happen on because of that? Okay, the first thing is uh, if you have a body, if you have a body which from the beginning it's stay still, means not moving at all. Okay, it will keep stay still. But if you have another things, another body which at the beginning is moving a bit, is moving in the moving condition. Okay, it will move with a constant velocity. Okay, it will move with constant velocity. And if you have a body, another body as well, which from the beginning it rotates with certain angular velocity. Okay, in that case, it will stay in the same. Uh, it will keep in the same angular velocity. Like that. It will rotate at the same angular velocity. Like that. Okay, so basically there will be no acceleration. What is happening if a body is in the equilibrium condition? There will be no acceleration. Uh, it's like this. The acceleration will be zero, and the angular acceleration will be zero as well. Okay, acceleration equal to zero, and angular acceleration equal to zero. This is what will be happening if a body is in the equilibrium condition. But luckily for you guys, okay, but luckily for you guys, yeah, uh, luckily for you guys, because it's statics, because we are handling with statics, right? So we will not talk about uh, moving things at all, right? So everything in the stationary position. So you don't have to care about this. What you have to care is the original location, the original condition is it is at a stationary condition. Then, okay, when equilibrium is happening, then it will stay still. That's it. Okay, that's the thing that you need to do. Okay, about these basic concepts. Anyone here want to ask question? Okay, for these particular basic concepts, I will not try to rush. Okay, I will try to teach you as slow as I can. Okay, but if it's too slow, please let me know. Anyone here want to ask question? Yes, please. No one? Okay, good. In that case, then I will continue. Okay, let me bring first. Okay, there are several categories of equilibrium. Okay, there are several categories in equilibrium. It depends on the forces which is happening in a body, right? Okay, there are several examples here. Okay, this is the simplest one, collinear, which means in a body, the forces which is happening is in the same line of action. So in that case, you can do it this way. Just create one coordinate, okay, create one coordinate in that line of action. In this case is x, and total it, total everything, and the total is supposed to be 0. Okay, the total force in the x, in this case is x, what you call it, coordinate, okay, is equal to x-axis, sorry, it's not coordinate, axis, I'm sorry. Try to create an axis in the same line of action, then the total force in the axis is supposed to be equal. If the total force in the axis is equal to 0, then it met the equilibrium condition. Okay, that's the first part. Actually, it is easier for us to do practice problem, but before we are going to the practice problem, okay, before we going for the problem for your exercise like that, I think I will just give you some information. Okay, the second one is concurrent at a point. This is the same problem as the problem that you are solving in the in our homework. Number one, okay, all the forces are met. You can all the line of action of the forces which is happening at one body like this. Okay, if you extend the line of forces, it will met at one point like this. Okay, in this case, you can solve it using this. Try to create a coordinate which has two axes because it's two-dimensional, x and y. Then the total force in the x direction and the total force in the y direction is supposed to be equal to 0 in order for the equilibrium condition to happen. Okay. Any question here before I move to the next slide? No question? Okay. Hey, why I touched the wrong button? Sorry. Sorry. Screen. Start now. Okay. 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 So that's the first problem. The first and the second problem. Okay. Now we have another case. Okay. If the forces is parallel like this. Okay. If the forces is parallel like that. In that case, okay. In that case, in order for the equilibrium to be met, okay, the easiest way, yeah, as usual, you create the coordinate. Then after that, because all the forces are happening at one direction, x, then the total force in the x direction is supposed to be 0. It's easy, right? Then the total moment is supposed to be 0 as well. In order for the equilibrium, in order for the in order for us to ensure the equilibrium happening. Okay. Sorry, any of you here having a problem in reading my writing? Because some people may feel that my writing is too bad, too not that good, not just not that good. Maybe one of the worst that you can ever seen like that. Okay? Anyone here having a problem in reading my writing? Matthew? Matthew?
No, I don't, sir.
Okay, good then. So if you don't complain, assume that everything is okay, right? Okay. Then
Sir, in the previous slide, may I see again the previous slide?
previous
In the 1 and 2 for
wait a
equilibrium.
minute. That's what.
Oh yes, and the one that's concurrent for a point, is there like any sigma moment equals to 0 that we need to like calculate or take account of?
You don't have to. I said, why you don't have to? Because all the forces here met at one certain point. So we can ensure that the sigma moment here, sigma moment condition here is met. Because if you calculate the sigma moment at point O there, okay, for sure you will be able to get the total moment there is equal to 0. Correct or not? Because all the perpendicular distance will be equal to 0 for F1, F2, F3, and for F4. That's why we don't need to calculate sigma moment here, sigma moment equal to 0 here, because for sure it's happening. Do you get it, Asan?
I see. Okay, then. Thank you, sir.
The same for this, Asan, and the rest as well. Okay, the same for this. Why we don't have to calculate sigma Fy equal to 0 here? Because there is no y direction force there. And besides that, we don't have to calculate sigma moment equal to 0 as well, because all the forces happening at one line of action. If I create one reference point here, for example, okay, for sure the sigma moment will be equal to 0. So we don't have to calculate here, this one, because 100% it will be met. Okay, you get it, Asan?
Okay, sir, I get it now.
Yeah.
Thank you, sir.
Okay, clear, stop, okay. But unluckily for you guys, right? Okay, unluckily for you guys, most of the problem are like this. So this is the general problem. So that's why, in order for us to, in order for you, in order for you to handle all the problem easier, okay, it is always good to treat all the problem as a general problem. Try to treat it using sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Because even though you have to treat it like this for this kind of problem, or for problem number 1 or problem number 2 like that, okay, you still can solve it. Okay, so general problem, because there is no simplification that we can do there. We have to calculate everything. You have to create the coordinates as usual, to axis, because it's two-dimensional, x and y. You have to calculate sigma fx equal. You have to total the sigma fx, and the total is supposed to be equal to 0. You have to total the sigma fy, and the total is supposed to be equal to 0. And the total moment is supposed to be equal to 0 as well. At any, you can choose any reference that you want for the sigma moment. But it is better for you to choose a reference which will make it easier for you to solve the next problem, to solve the problem. Okay, I think for some of you it might be too abstract, because we haven't handled the we haven't gone to the exercise yet. Okay, I think it's better for us to go to the exercise straight away after this. Clear? Okay, but before we are going to the exercise, you have to remember about several simple problem. Okay, several things. Okay, sometimes we have a mechanism with with which involve several member or several links like this. Okay, if the force is only happening at both ends like this, and the force direction is in the same line of action like that, we call that member as two force member. But remember, but you don't have to worry about this now, because this will be our focus in the next 2 weeks when we talk about fast. Okay. Then, if several forces happening at one body, but 3 forces happening at one body, but all the forces are going to one point, like this. Okay. Then in that case, okay, then in that case, we call that as a 3 force member. Okay. Okay. Before I go to the practice problem, I think it's better for you to understand about the basic concept first. In order for us to solve any kind of problem in the statics, okay, the first thing that you're supposed to do is to draw free body diagram. How to draw it? It is better for me to go. It is better for me to teach you on how to draw it by using several problem for exercise. Okay, and after that, you have to identify the known and unknown variables. Then after that, then implement this. First, enter Newton's law to solve for the solution. Okay, so that's the step-by-step on how us can solve problem in statics. Most of problem in statics, we use this kind of way to solve it. Okay. So this is the first problem, because I want you to practice on how to create a free body diagram. This is the first thing that I want to teach on how to draw the free body diagram. Okay. Can you guess what kind of problem is this, guys? Huh? Can you guys? Can you guess? No? Okay, in that case, I will point out some of you. Pasadiara.
Yes,
Hello,
sir.
Pasa. What kind of problem is this? Oh. Can you guess what kind of problem is this? Where it normally happens?
I actually don't know.
Does it look like a simple bridge like that, Fasa? Just a beam in between two sides like that, and it connects one and the other. Can it be like that, Fasa?
Yeah, I think so.
It can be like that. Okay. Now, the things that I will ask you is, Fasa, okay? The thing that I will ask you is, if I ask you, what is the forces happening at point A, and what is the forces happening at point B? Okay, at the join A and join B here. You can see, right? There is a join there, right?
Yeah.
So I'm asking you, what is happening at point A and point B, and what are the forces happening at point A and point B? Fasa, how
Uh,
can we solve that, Fasa?
um, is there any normal force?
Yes, of course, but we have to try to take a look at the type of join which is happening there, right? Fasa, in order to determine what kind of forces which will be happening there, right, Fasa?
Yeah.
Okay. Uh, Thank you, Fasa. Okay. Now I want you guys, all of you, to take a look at this particular picture and try to analyze what kind of forces which can be there at point A and point B at the join there. Okay. Ignore all the external forces. Ignore this, and ignore this. Okay. What I want you to do is just focus on those A and B and think about what forces which can be there at point A and point B due to the join there.
Maybe way, sir.
Wait. Oh, what? Matthew?
Yes.
Wait. No. I'm not talking about. Wait. I'm not talking about anything. But the direction of force which can be produced due to join A and join B at point A and point B. What do you think, Matthew?
Uh, what do you mean, sir? Do you mean like if I look at A, what does
Mhm.
B does to A? Is that your question?
No, if you take a look at A and you replace the join which is happening at A with external force, what is the direction of the external force which can replace the join A like that in order for the system to be in the still equivalent with the in order for the drawing, the free body diagram, to be still equivalent with the problem that we are talking about. The same for B as well. You get it,
I
right?
think it's either upwards or downwards, sir.
Why you think like that? If I want to replace this joint, what it looks like that, right? It looks like a pin like this way. There is a joint here, okay? And that joint is connected to point A, right? There. What I mean is, I want to replace the joint there, joint A. Delete. I want to delete the joint A and replace it with force at point A because I need that to solve the problem. Okay?
So sir, let's say you take a look at B.
Mm-hmm. No. A
If we
first.
take a look,
A first, Matthew.
if we
Just
take a
now
look
you
at
just now you are talking that we can replace it with upwards or downwards. Why you think like that, Matthew? Only
to be
upwards or
honest, I
downwards?
don't know, sir, because it just seems like it.
Okay, because as you can see, right, it seems like there is a like a square, not square, it's a roundly shape there, right? If you have a round shape there, most of the time it will not be possible to withstand horizontal force, right? Correct or not, Matthew?
Will not be able to withstand what, sir?
Horizontal force.
Pardon, sir.
Horizontal force. Horizontal.
Horizontal force. Yes, I
Correct,
agree.
right? Yeah. The same as this one as well. This kind of joint. If the joint is like this, like a roller like that. So this kind of joint is actually quite similar to this roller joint. Okay, if we have a roller joint like this, what kind of force, okay, which can be exerted from the joint to the point, Matthew?
Vertical force.
Only vertical force, the same. These two are the same. So this kind of joint, either like either like this, okay, or like this, just like a roller like that. Okay, they can only produce only vertical or only upwards or downwards. So either vertical or either upwards or downward force. So only vertical force. Okay. But now let's take a look at this kind of joint. We call this as pin joint because there is we fix it here. Okay, we fix it here like that. We fix it there. We fix it there, and against point B like that. So for this kind of joint, what kind of force which the joint can exert to point B, Matthew?
All direction.
All direction. Okay, all direction. So it can go to all direction, but it will be difficult for us to draw all directional force. So actually, I can just represent it with two forces, x and y. Why? Because fx and fy, if the magnitude is not yet known, okay, the total force can be anywhere, right? The total force of fx and fy, if the magnitude here is not yet known like that, it can be the total force between fx and fy can be there, can be in that direction, can be in that direction, can be like this, like this, like this, like that. You get it, Matthew?
Yes, sir.
So actually, by drawing like this is supposed to be enough.
Sir, actually, what contraption is this?
Hmm?
What contraption is this?
Construction, you mean?
Yes.
It's
Is it
some
a
kind of
gate or something?
no. It's some kind of simple bridge like that, Matthew. So it's something like this, right? It's simple bridge. So this, and normally in the bridge, we have one roller and one pin, and the other side. So it's a simple bridge like that. Okay, Matthew.
Okay, sir. I get it.
Anyone here? Do you get it? What my explanation just now?
I
Everyone
still
here.
don't. I still don't understand what the roller does. Is it only vertical?
Have you played rollerblade before, Ananda?
Maybe not.
Maybe not.
I'm not so sure.
You never played rollerblade. Okay, then in that case, what can? I'm so sorry about the distraction there. So whenever it's happening, just ignore it. Okay. What can? Or have you ever played ice skating before?
Yes, I have.
Okay, but the principle of ice skating and the rollerblade, although the way
Oh, rollerblade.
slightly, yeah, rollerblade, yes.
Oh yeah, I never played, but I know it's.
Yeah. Okay, then try to imagine rollerblade. Okay. Okay, rollerblade. It has the same effect as this kind of roller pin, because basically rollerblade has several roller pin below the shoes, right? And okay. Now, if you stand on the rollerblade, try to imagine it. If you stand on the rollerblade, okay, can the rollerblade withstand your weight?
Yes, it can.
So you are now moving vertically, right? You are not accelerating vertically, right?
Oh, just standing right, sir?
Yeah.
Yes.
Yeah. Okay. Now the next question: if suddenly So yeah, Asher, if suddenly Asher push you from behind. No, I'm still talking with you.
Yes.
If suddenly, if you are still on top of your rollerblade, okay,
Mhm.
using your rollerblade,
Mhm.
standing still, then
Mhm.
Asher push you from behind.
Okay.
What will be happening? What will happen to
I
you?
will be moving horizontally.
Moving horizontally, which
Uh,
means rollerblade cannot withstand horizontal force, right?
Probably cannot.
Not probably. No. Just think about the logic behind my story just now. Okay, if it can withstand horizontal force, then when Azer push you from behind, you will still stay still.
No, I will be moving, right?
You will be moving.
If
In that
I
case,
move.
rollerblade cannot
Yes.
withstand the horizontal force, right?
Oh, I see. You mean it will move if it's pushed horizontally.
Yes,
Ah, I see.
correct.
Okay.
That's why whenever we have a roller pin in one hand, okay, that
Mhm.
roller pin cannot withstand the horizontal force. It can only withstand vertical force.
Oh, okay.
That's why we can replace this kind of roller pin with force like this, either upwards or downwards. But we can replace this pin joint with force like this because it can withstand
Both
both
horizontally and
horizontally and vertically.
vertically.
Okay, do you get it now?
Okay. I get it.
Good. Okay, anyone here still having a problem with this?
Pak, jadi kita nggak peduli bentuk si itunya kotak atau apa karena udah ada join barunya ya?
Maksud kamu gimana?
Kan tadi katanya kalau misalnya bulat tuh, itu kan cuman kayak ada vertical force-nya doang. Bakal susah ada horizontal. Cuman di sini kita udah nggak peduli karena udah ada kayak join barunya gitu ya, Pak? Udah ada si titik yang ini nih, yang tebel.
Titik tebel itu yang mana? Yang ini bukan? Ini
Iya,
ini.
karena udah ada itu.
Ya, itu intinya adalah kita ingin mencari tahu gaya yang bisa ditransferkan dari pin joint dan juga dari roller joint ke titik tersebut. Intinya itu.
Okay.
Karena kita tidak boleh menggambarkan pada saat kita just now remember about this, right? Just now I told you that the first step for us to solve the problem, why it's like this. The first step for us to draw to solve the problem is to draw the free body diagram, right? Okay, to draw the free body diagram, correct? Right? Just now, remember this one. This is the first step whenever for us to solve when we want to solve the problem, all statics problem. Because previously I just give you last week, previous week, and before I talk about the free body diagram, I just give you like all the basics. But now we will go to the main course. Okay, in order for us to solve a statics problem, we have to start with the free body diagram, always like that. So drawing the free body diagram is one of the first steps to solve the problem. Then after that, identify known and unknown fibrils. Then after that, solving the problem using Newton's law, which is basically just sigma fx, sigma fx equal to 0, sigma fy equals 0, and sigma moment equals 0. Then calculating solution. So that's the step-by-step to solve the problem, always like that. So now, what I'm trying to imply here in this discussion is how to draw the correct free body diagram. You get it, Rizky?
Yes, Pak.
So, and in order for us to draw the free body diagram correctly, we cannot draw the pin, we cannot draw the joint anymore. We have to replace those as an external force. Okay, so we cannot draw this pin anymore. We cannot draw this pin anymore. We cannot draw this pin. Sorry, we cannot draw this pin anymore. We cannot draw this roller pin anymore. We cannot draw it like that for the free body diagram. We have to represent those. We have to replace those pin or those roller pin or those fixed pin or fixed joint like that with external force, which can replace those kind of pin, and the effect will still be the same. You get it, Rizky?
Yes, Pak.
Yeah. So that's basically it. So if I want to draw the free body diagram of this particular problem, then yeah, I will redraw the pin. Okay, then I will draw all the external forces which is there already. Nice. Okay. Why is like this? Sorry. No, I can't. Okay. There is no option of anyway, I will just redraw it then. Yeah, I will just draw it using this. Hopefully it's getting better. Okay. Then we have this. Then we have this. 200 and 100 and what else do we have here? External forces there is no way there. Adila.
Yes, sir.
Okay. What else there which I haven't drawn there in my free body diagram?
The external force.
Which one?
The 600. Yeah,
600,
the 600
correct.
newtons.
600 Newton, correct. I have to draw it here. 600 Newton. Okay. And while drawing the free body diagram, you have to draw all the dimension correctly as well. So you have to draw the distance like that. Okay, because the meaning of the meaning behind free body diagram is you can represent the problem with one drawing, which complete with all the dimension and all the information that we're supposed to have. Same as this one, we're supposed to have 45 degrees. Here we have 2 meters. Here we have 3 meters, 2 meters. Okay. Thank you, Adila. Now, Rafi Gyasi. Hello, Rafi.
Yes, sir.
Rafi, I'm asking you now. Does my free body diagram, this one, okay, this free body diagram is already complete, Rafi?
I don't think so.
What is lacking there?
We need to add external forces to represent the hinges in A and B.
Correct. Okay. Now, for you first, in order to replace the roller joint there, what external forces that I supposed to draw here?
We need to draw one going upwards and one.
Not necessarily. Just one direction is supposed to be enough. Okay, because it's just representative actually, Rafi. You get it, Rafi? So just force which is representative of the of the reaction force which will be happening. Okay, so we can just draw it like this. AY like that.
Okay.
Okay, because it's just a representative. Now, Rafi, I want you to point out one of your female friends to help me for the pin joint. Who? Hello, Rafi.
Hello.
Yeah, your voice is seems like you have problem with your mic. Just say one name. Like that. Yep. Who want to choose? Wait a minute. Hold on, sir.
Is broken.
Oh, in that case, because Rafi takes too
Hello,
long.
hello, sir.
Yeah. Okay. Who you want to choose, Rafi?
I'll choose Shabina, sir.
Shabina. Okay, Shabina. Because Rafi picked you, then I will go to you. Shabina.
Yes, sir.
Okay. Now, I want you to replace this pin joint into external forces, which can represent the pin joint. Please help me to draw the external forces, which can represent the pin joint. How's that, Sabina?
I'm sorry, sir. Actually, I don't really understand about this. I actually really understand about the material after I watch the recording again. So I'm not really focused in class.
You are not really focused in class. Why you are not really focused in class, Sabina? Because my way of teaching is too boring, or what?
No, sir. Is it because I think it's in the morning?
In the morning? How about tomorrow morning? it's early in the morning. Today is not that more. Sabina, it's just 30 minutes before noon, Sabina.
Yeah.
Yeah, I know. In English, we still call this as a morning, not 30 minutes before noon, Sabina. Okay, so I believe you're supposed to be connected already. Yeah? No, not yet.
Not really, sir. I'm sorry.
Oh, you are kind of a night person, or what?
Yeah, I actually go to bed at 1 or 2.
Okay. Okay then. Anyway, because your friend already choose you, but like it or not, you have to help me to answer it. So try to imagine if you have a pin.
Yes,
Like
sir.
that, if you have a pin, can it instead pin like this? Okay? Can it withstand horizontal force or not? Shabina?
Yes.
Yes, it can withstand horizontal force. How about vertical force? Can it withstand vertical force?
X and Y.
Yeah. Horizontal X, Y is vertical, right?
Yeah.
Can it withstand vertical force as well? Hello, Shabina? Shabina?
The X, sir.
Beside, so just now you told me that yes, it can withstand horizontal force. Now I'm asking you, can it withstand vertical force as well?
Yes.
Okay,
To the upward.
Yes, correct. It's like this. Higher. Okay, so it can withstand both vertical or horizontal force, Shabina. So because it can withstand vertical force, I can draw Py here.
Okay.
And because it can withstand as well a horizontal force, I can draw Px. px and py, it representing actually the pin joint there. Do you get it, Sabina? The same as ay here is actually representing what the roller joint can give to point A, like that. So actually, those three forces, ay, px, py, is actually can replace the roller joint here and pin joint here. Do you get it, Shabina?
Oh, yes, sir.
So this is it. This is how we draw the free body diagram correctly. All the external forces supposed to be there. Okay, that's the one thing. And all the pin joint, all the joints, you're supposed to all the contacts, you're supposed to replace it with external force as well. Do you get it, Shabina?
Oh, okay, sir.
Yeah, good. Anyone here still having a problem with this? So this is how can we draw the free body diagram correctly. Okay, so this is the way to draw the free body diagram correctly. Okay, because just now I told you, right? The question here is, what is the reaction force? Reaction forces at point A and B due to roller joint and pin joint there. So that's the main question there. That's the question that we're supposed to answer. So the reaction forces there is actually represented by ay here, py and px there. So this 1, 2, 3, those three actually representing all the reaction force that can happen to the pin. Do you guys understand? Hello, I need your feedback, guys.
Yes, sir.
Good. So the one that I try to make it bold, slightly bold, is all the external forces which is happening to the system. Okay, now if we try to remember again what we have in this particular slide. Okay, after drawing the free body diagram, what we're supposed to do after that? We're supposed to do this like identify known and unknown variables. Okay, now let's go back here. Can anyone here help me to point out which one is the known variables and which one is the unknown variables? Anyone?
The BX, Pak.
Who's this?
Rizky.
Uh-oh. Why is like this?
Isn't it supposed to be by because it's already parallel to the y direction?
Sorry. I think I need to fix something first. Wait a minute. Because I clicked the wrong button, so the recording is going haywire. Wait a minute. Okay. Seems like there is a problem with here. Stop share. Share again. Screen. Okay. Start now. Okay, sorry again. Just now. Which one is the known variables and which one is the unknown variables? Just now there are two of you who already try to answer my question. Who was that just now? Secret or not? Who was it just now? Oh, Asyan. Hello?
Yes, sir.
Yep. You try to answer my question before.
To me, I think the known variables here like are the by forces because they're like directly parallel to the y-axis, and the more more unknown variable here is the
Yeah, okay.
dx.
Let's try to list it up. Okay. What are the known variables and what are the unknown variables?
Oh, the
What do you
length
think?
of the bridge. First
No.
of all, the length.
Yeah, the length of the bridge is okay. Everything is okay. What I mean by known variables here is just the forces and moment which is happening there.
Oh,
So can you listen?
the 100 newtons, the
100 newtons there, and what else?
200 newtons,
200 newton,
and
and what else?
45 degree 600 newton
600
force.
newtons. Okay, 600 newton with 45-degree angles like that. Okay, now the unknown variables.
Oh, the resultants.
The unknown variables. Some things that yet known the value. You don't have the value yet. 100 newtons, we know the value and the direction as well. It's going down, and the value is 100 newtons. 200 newtons is the same as well. It's 200 newtons. The magnitude is 200 newtons, and it's going down. So we know the values. We know the direction. 600 newton is the same as well. We know the direction. It's 45 degrees to the down right. Okay. And the magnitude we know as well.
Because we are yet to calculate it.
Yeah, sorry.
So that makes the bx and the by unknown because we are yet to calculate.
Correct. Yes, because we yet to know the values, right? We yet to know the values. We know the direction. Bx is most likely going to the right or left. By is most likely going up or down. Ay is going up or down. But we are not yet to find the values yet, right?
Yes.
So we're supposed to list it up. Bx, by, and ay. This is the unknowns that we're supposed to solve. This is the known things for us to be used to solve this, beside all the dimension here. You get it, Asar?
Yes, sir.
So we're supposed to solve for bx, by, and ay. But we know all the data here. Or we know 100 newton, 200 and 600 newton and all the direction. And we know all the distances like that and all the angles like that. So we have all the unknown values and we have all the unknown values. Okay, sir?
Okay, sir.
So now we finish the second step. So second step checklist. We check it already. Now the third step. What was known as the third step?
The step is to implement the first and the third laws of Newton.
Correct. The first step is to implement the third step is to implement the first and the third Newton's law. So basically, try to solve for the bx, by, and ay. Okay.
Okay.
So basically, we just use this sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Okay? These three equations. You can use those three equations. Remember, if we have three equations, we can solve for, if we have a certain number of equations, we can solve for the same number of unknowns, right? Asad?
Yes.
So if we have three equations, sigma fx equal to 0, sigma moment equal to 0, sigma fy equal to 0, can we solve for three unknowns?
For Yes, sir. I suppose so.
Yes, we can solve for 3 unknowns. We can solve 3 unknowns. So actually, we can solve for this, and this by implementing this equation.
Yeah.
Okay.
Okay.
Do you get it, Asad? Okay. For this particular problem, because this is the first problem that we discussed together, I will try to solve it for you guys. So later, you can rewatch it in the video. Okay. So for example, sigma fx equal to 0. That's the first thing that we're supposed to solve for. What are the forces which is happening there? Okay. What are the forces which is happening there and has a horizontal component or x component? Who else here? Wait a minute. I think I need to call somebody else. Nia Aulia. Hello, Nia.
Yes, sir.
Yeah. Can you point out what are the forces which has horizontal component, x component?
It should be bx and 600 cos
Yes.
45.
Yes, correct. Okay, supposed to be bx and 600 cos 45. So this is the first equation that we want to solve. Sigma fx equal to 0. So all the equation that we have, okay, 600 newtons is going to the bottom right, right? So if 600 cos 45 means that 600 cos 45 is going to the right, right? Yeah.
Yes, sir.
Okay. Then I assume that going to the right is positive. So we have 600 Newton cos 45 degrees. Okay. What else is going horizontally?
bx.
Bx plus bx. Why plus? Yeah.
Because it's going to
The right. Yeah, because it's going to the right. Remember, right? Going to the right is positive. I define it from the that going to the right is positive, right? This here.
Yes.
Anything else? Going horizontally. Nothing, right? That's all.
No.
So this is our first equation. Going to the right positive. So this is our first equation using sigma fx equal to 0. Now, this is actually we can solve it, but I will solve it later. Sigma fy equal to 0. I assume going up is positive. Now, going up is positive. Still, Nia, try to help me to solve it. What forces which is going up or down vertically? So going vertically.
by.
Ui, what else?
ay.
Ay.
And for down direction is 100 newtons.
And 200 newtons.
200 newtons. And
Oh.
600 sin 45.
It's going down as well. Okay. So just now we have by plus ay because it's going up, right? So positive.
Yes.
Minus 600 Newton because it's going down, negative. Minus 200 Newton because it's going down, negative. Okay. Minus 600 Newton sin 45 degrees because it's going down as well, negative, equal to 0. So I will take a look again here. Okay. 600 Newton is going down, negative. 200 Newton is going down, negative. By is going up, positive. Ay is going up, positive. And this one, 600 Newton sin 45, going down, negative. So it's correct, right? Yeah.
Yes, sir.
So this is our second equation. Now the third equation, sigma moment equal to 0. Still near. Sorry to hold you up for too long. Okay. Which point that you want to use as a reference? Yeah.
B.
Why B? Yeah.
Because
Or you just choose it random?
yeah.
But actually, you choose the best point. Okay, because
Okay.
whenever we choose a reference, right, actually you can choose it anywhere you want, guys. Okay, for all of you guys. Okay, actually we can choose anywhere you want for the reference point. But the best, okay, the best one, okay, the best reference point is the location, is the point where you can delete, you can delete more unknowns. At B, we have two unknowns, right? Yeah.
Okay, okay. So
So
I have
actually,
to.
so actually you
It's
choose the
supposed to
correct.
be 100 Newton.
Sorry. No. You
Or
choose you choose the correct
oh,
point.
oh yeah, okay.
So this one, sigma moment at B equal to 0. This is our third equation.
Okay.
You want it clockwise positive or sorry. You want it clockwise positive or anti-clockwise positive?
Clockwise
Counterclockwise
positive.
clockwise positive. Hey, I will follow you. Clockwise positive. So this is our sign. Okay? Then let's take a look at our free body diagram. Now B is our pivot. So we don't have to consider all forces which is going through B, right? Because the moment arm is equal to 0. Correct? Yeah.
Yes.
So we don't have to consider. So we don't have to think about the moment due to 200 newtons. We don't have to think about the moment due to Px. We don't have to think the moment due to Py. Correct, right?
Okay.
Because everything is equal to 0. Yeah. Although you can still put it Px multiplied by 0 plus Py multiplied by 0 plus 200 Newton multiplied by 0. Everything is 0. Correct, right? Yeah.
Correct, sir.
Okay. Then what else that we have there, which will cause moment at point B? Let's do it one by one. Everything will give an effect, right? Let's do it one by one. How about 100 Newton? Yeah.
So 100 newtons.
Will it give a moment to point B?
Sorry, sir.
Will 100 newtons there? This one. This 100 newtons. Okay. This one. Will it give will it produce moment to point B?
Yes, sir.
Okay. And what is magnitude then?
100 multiplied by
100
2
Newton.
meters.
But remember, it's clockwise or anti-clockwise?
Can I see anti-clockwise?
Yeah, the center of rotation is B. So anti-clockwise. So positive or negative?
Negative.
Negative. Negative 100 Newton multiplied by
2 meters.
2 meters. 100 Newton multiplied by 2 meters. Now the next one. What else there? How about AY?
AY.
Will it give an effect to point B as well?
Yes, sir.
Okay, so
AY. Positive.
Positive because it's clockwise, right? The point
Yes.
is point B, so AY will give a clockwise moment. So it will be plus AY multiplied by the distance.
7.
2 plus 2 plus 3, so 7 meters. 7 meters. Now the last one is due to 600 Newton. The easiest way for 600 Newton like this is you all can divide the 600 Newton into two. 600 Newton cos 45 and 600 Newton sin 45. Okay, 600 Newton sin 45. Cos 45, the horizontal one. Will it give an effect? Will it give a moment to point B?
Yes, sir.
No, horizontal. The horizontal one.
Oh, yeah.
No, it will not, right? Because if it's horizontal, there will be no moment arms there, right? If it's the vertical one, yes, it will give an effect. You get it?
Yes.
So in this case, we will plus as well. Just now 600 Newton. Okay. sorry, this one is cos 45, yeah? Cos 45 degrees in order to make it completely, but the moment arm is 0, so it will be 0 as well. Okay, then the last one is 600 Newton sin 45, right?
Yes.
600 Newton sin 45 will give moment clockwise or anti-clockwise?
Yes.
Counterclockwise.
Anti-clockwise.
Anti-clockwise. So negative or positive?
Negative.
Negative 600 Newton multiplied by sin 45 degrees. And the moment arm? Yeah. Why I cannot do? Just know what was the moment arm? Just know, this one.
5 meters.
5 meters. Multiplied by 5 meters equal to 0. If I ask you, can you solve for this? Okay,
Yes.
can you solve for AY, BY, and BX? Can we solve for that? Yeah. Hello, Nia? Can we solve for AY, BY, and BX?
No for BX and BY. Just for AY.
Everything we can solve it. Try to take a look at the first equation. The first equation here, we can solve for BX, right?
Oh yeah, sir. We can.
So BX here is equal to minus 600 Newton cos 45 degrees, which you have to calculate, okay? Okay, so
Yes.
the value is supposed to be something minus something I think Newton. Okay, then B1 and AY here we cannot solve it directly. Okay, but this one this one is 0, this one is 0. What else here in the third equation? This one is 0. So we only left with this, and this. So we can solve for AY, right?
Yes, sir.
AY there will be equal to 100 Newton multiplied by 2 meters, then plus 600 Newton multiplied by sin 45 degrees multiplied by 5 meters divided by 7 meters. This is your AY. After you got the AY here, then you can solve for BY here, right? In the second equation.
Yes.
That's it. Everything can be solved. So BX is there, AY is here, BY can be solved. That's the way to solve it. You get it, yeah?
Yes, I get it, sir.
Okay. Anyone here? Can you follow me on how to solve this after you draw the figure diagram? Hello? Guys? Nicholas? Can you catch up with me, Nicholas?
Yes, sir.
You understand, Nicholas?
I'm still a bit processing.
Speed processing.
Yes.
Okay. In that case, it's better for you to rewatch the video. I will try to post it as soon as possible. Okay.
Thank you, sir.
But that's the way it is. Okay. Matthew, you understand, Matthew? Don't worry for those who still don't understand. Tomorrow I will still give you some problem to practice. Okay, and we will discuss it tomorrow. So tomorrow it will be full problem example. So please.
So it's not a homework.
Not yet. The homework I will give it after the class tomorrow.
Okay.
Of course, every week we will have a homework. You will, not me. You will have a homework. Okay, in order for you to keep practicing all the time.
Sir, I
Okay,
have.
Okay, Fazadira, yes. Fazadira, yes.
For the previous problem.
Okay.
How about the weight of the beam?
Sometimes if the weight of the beam is not put there, is not there in the problem, sometimes it is ignored.
So in this particular
In
problem,
this problem, the weight of the beam is ignored. We can ignore the weight of the beam.
okay, thank you, sir.
But if in the problem is stated that the weight of the beam is, for example, 100 newtons like that, then in that case, you have to add up. You have to add another force here to represent the weight of the beam. Do you get it, Fasadia?
Yes, I get it.
Something like that. Okay, I think it's enough for today because it's already close to noon, and I'll try to post the video as soon as possible. And for you guys, please wake up early tomorrow so we can have a discussion tomorrow on the other problem example. Okay. Just now, who told me it's very hard to. Okay, Shabina, I will check whether you attend my class or not tomorrow morning. So try to wake up early tomorrow morning. Okay, Shabina?
Sir, actually, I always attend your class.
But while sleeping.
Half sleeping.
Half. Okay then. Anyway, I think that's all for today. Okay, see you guys tomorrow. Okay.
Thank you very much, Pak
Thank you, sir.
Satrio.
Okay, sir. Thank you, sir.
Thank you. Bye bye.
Thank you, Pak.
Thank you, sir.